In this question, we have to find integration of this function from -1 to 1. Basically, here we have two different functions. Let's say your first function is f1x and second function is f2x, and your limit is from -1 to 1. That means you have symmetric limit. So let's check both function whether they are even or odd. So here your first function is x raised to 2013 upon e raised to mod x into x square plus cos x. Let's find out f1 minus x. Then we just have to replace our x by minus x. So in numerator we will get minus x raised to 2013, and in denominator we will get e raised to mod minus x into minus x the whole square plus cos of minus x. So 2013 is odd number, so here we'll get minus x raised to 2013. In denominator, due to mod, we will get e raised to mod x, and x square and cos x both are even function, so we will get x square plus cos x, right? So as you can see, we get our function with negative sign. So your f1 minus x is nothing but minus fx. Therefore, your f1 is odd function. Therefore, we can say its integration from -1 to 1, let's say it is I1, will be 0. Similarly, if we check our second function, which is 1 upon e raised to mod x, and for that we have to find out f of minus x. So here we'll get 1 upon e raised to mod of minus x, which will be equal to 1 upon e raised to mod x, which is your function itself. So your second function is even function. So integration of second function, let's say it is I2, will be 2 times integration from 0 to 1, 1 upon e raised to mod x. And we know that your x is belongs to 0 to 1, and in this interval your mod x will be x. So here we just have to integrate e raised to minus x, which is simply e raised to minus x upon coefficient of x, which is -1. Limit is from 0 to 1. Here we'll get -2, and from upper limit we will get e raised to -1, and from lower limit we will get e raised to 0, or here we'll get 2 times e raised to 0, which will be 1, minus e raised to -1. So finally your total integration, which is I1 plus I2, will be 0 plus 2 times 1 minus e raised to -1, which is given in option D. Ta-da! We have to integrate log 2 minus sin x upon 2 plus sin x. Limit is from minus pi by 2 to plus pi by 2. So here we have symmetric limit. So let's check our function is odd or even. We have log of 2 minus sin x upon 2 plus sin x. So let's find out f of minus x. That means we have to replace our x by minus x. So we will get log of 2 minus sine minus x upon 2 plus sine minus x. Now we know that sine is odd function. So we will get log of 2 minus minus become plus sine x upon 2 minus sine x. Here within the bracket we have reciprocal what we have in the function. So let's write down inverse of 2 minus sine x upon 2 plus sine x. Now according to property of log, we can take this negative sign within the multiplication of log. So here we'll get minus of this is your function f of x. So we can say f of minus x is nothing but minus fx. That's why your function is odd function. Therefore, integration will be 0, which is given in option D. Ta-da! Here we have to integrate 1 upon 1 plus cos 2x. Your limit is from minus pi by 2 to plus pi by 4. So we can say our limit is symmetric. So we have to check function is odd or even. So first of all, let's get our function, which is 1 upon 1 plus cos 2x. Now let's find out f of minus x. That means we just have to replace our x by minus x. So in denominator, we will get 1 plus cos 2 times minus x, which is nothing but 1 upon 1 plus cos 2x. So here we get f of minus x is equal to f of x. So your function is even. So we can say your integration will be 2 times 0 to pi by 4 of 1 upon 1 plus cos 2x. Now, before we go for integration, let's simplify. In denominator, we have 1 plus cos 2x, which can be rewrite as 2 cos square x. So this 2 will cancel out. We just have to integrate 1 upon cos square x, which is sec square x. So integration of sec square x is simple. 10x. Limit is from 0 to pi by 4. Now let's substitute limit. From upper limit, we will get 10 pi by 4. And from lower limit, we will get 10 0. The value of 10 pi by 4 is 1 and 10 0 is 0. So your final answer is 1, which is given in option A. Ta-da! If P is equal to integration from 0 to 3 pi function of cos square x dx and Q is integration of function of cos square x but from 0 to pi, then we have to find relation between P and Q. Here we have P is equal to integration from 0 to 3 pi, and we can split this into 0 to pi, pi to 2 pi, and 2 pi to 3 pi. We have function of cos square x. Now cos square x is actually repeat itself after 0 to pi. Pi થી 2 pi માં ફરીથી એ વેલ્યુઝ રિપીટ થાય and 2 pi to 3 pi ની અંદર બી same values repeat થાય. So we can say integration from 0 to pi will be as it is, and integration from pi to 2 pi is same as 0 to pi, and integration from 2 pi to 3 pi will also same as 0 to pi. So here we'll get 3 times integration of 0 to pi function of cos square x, or we can say we have P is equal to 3 times Q, or we can rewrite as P minus 3Q is equal to 0, which is given in option C. Ta-da! We have to integrate from 0 to 2 pi 1 upon e raised to sin x plus 1. Now, to solve this, let's use our fourth property. We can replace our x by summation of the limit, which is 2 pi plus 0 minus x. So our function will be changed as 1 upon e raised to sin 2 pi minus x plus 1. Now we know that sin 2 pi minus x will be minus sin x, or we can say it is reciprocal of e raised to sin x. Now for simplification, let's take LCM. So this e raised to sin x will multiply with 1, and we will get 1 plus e raised to sin x upon e raised to sin x. Now we know that denominator of the denominator will move in numerator. So here we'll get integration 0 to 2 pi e raised to sin x upon 1 plus e raised to sin x. Let's say this is your second equation and equation number 1. Now let's add equation number 1 and 2. In left side we have I and I. So I plus I will be 2i. And on left hand side of the first equation is 1 upon e raised to sine x plus 1 plus right hand side of the second equation should be moved over here. Now, right hand side, the denominator and limit will be same, and we just have to add their numerators. In first numerator, we have 1, and in second numerator, we have e raised to sine x. So here we have e raised to sine x plus 1 in numerator as well as denominator. So they will be cancelled out, and we just have to integrate 1, which is x. Limit is from 0 to 2 pi. So here we get 2 pi minus 0 equal to 2y. So we can say your I is simply pi. Can be considered as your final answer, which is given in option A. Ta-da! Here we have to integrate sin x minus x cos x upon x into x plus sin x from pi by 6 to pi by 3. जो एक्चुअली છે ને અહીંયા x cos x છે અને અહીં sin x છે અને નીચે x sin x છે ને x અલગ અલગ છે. તો एक्चुअली નીચેના ફેક્ટર્સ ઉપર લાવવાનો ટ્રાય કરવાનો છે. બંને ટર્મનો કોઈ એક એક પાર્ટ લઈ લેવાનો. આનો કોઈ ટર્મ 1 લઈ લો અને આનો x લઈ લો તો બી તમે x એડ એન્ડ રિમૂવ કરી શકો. x એડ એન્ડ રિમૂવ કરશો તો તમને x sin x બી મળી જશે ને અહીંથી x કોમન બી નીકળી જશે. Now to simplify this, let's add and remove x. So here we'll get x plus sin x, and here we'll get minus x cos x. Your denominator will be same. Now for further simplification, in first term we have x plus sin x, and from rest of the two terms we can take minus x common, so we'll get 1 plus cos x. And let's give individual denominator. So this x plus sin x will cancel out in first term, and we will get 1 by x. And in second term, x will be cancelled out, and we will get 1 plus cos x upon x plus sin x. So we are ready for integration. Integration of 1 upon x is simply log x minus, in second term, if we select our denominator as your fx, we already have its differentiation in numerator. So its integration is simply log mod denominator, which is x plus sin x. Your limit is from pi by 6 to pi by 3. Now, before we substitute the limit, let's simplify. We have log a minus log b, which can be rewritten as log of a by b. So here we'll get log of x upon x plus sin x. Limit is from pi by 6 to pi by 3. Okay, now we are ready to substitute limit. From upper limit we will get log of pi by 3 upon pi by 3 plus sin pi by 3, minus from lower limit we will get log of pi by 6 upon pi by 6 plus sin pi by 6. Now substitute the value of sin pi by 3, which is nothing but root 3 by 2, and sin pi by 6 is simply 1 by 2. So in further simplification, we will get log pi by 3 upon, if we take LCM, we will get 2 pi plus 3 root 3 whole divided by 6, and we can move this 6 in the numerator. So here we'll get 6 pi by 3, or we can say 2 pi. Similarly, in second term, let's take LCM. So we will get pi plus 3 pi. Now here we have log a minus log b, which can be rewritten as log of a by b. So here we'll get log of your a, which is 2 pi upon 2 pi plus 3 root 2, and upon b, or we can say reciprocal of second term, which is pi by 3 upon pi. So your pi will cancel out, 2 will multiply with pi by 3, we will get log of 2 times pi plus 3 upon 2 pi plus 3 root 2 as your final answer, which is given in option A. Ta-da! In this question, we have to integrate mod cos x from 0 to pi. Here, your lower limit is 0 and upper limit is pi. And your function is cos x within the mode, right? Let's try to check your f of a minus x, or we can say f of pi minus x. So we just have to replace our x by pi minus x. Now cos pi minus x is minus cos x, but due to this mode we will get mod cos x, which is nothing but your function of x. So here we get f of a minus x is equal to fx, and for this condition we can say your integration will be 2 times integration from 0 to half the limit. So it will be pi by 2 mod cos x. Now we know that when your x is belongs to 0 to pi by 2, or we can say in first quadrant, your cos x is positive. So we don't have to worry about this mode. Integration of cos x will be sin x. Limit is from 0 to pi by 2. So we will get 2 as your final answer, which is given in option C. Ta-da! In this question, it is given that integration from a to 0, x square minus 1 upon 1 minus x is equal to minus 1 by 2. And we have to find the value of a. So let's simplify. Integration from a to 0. In numerator, we have x square minus 1. So we can split into x minus 1 and x plus 1. And in denominator, let's take negative sign common. So we'll get x minus 1. On right hand side, we have minus 1 by 2. So this minus minus become plus, and x minus 1 will be cancelled out. So we just have to integrate x plus 1. So integration of x will be x square by 2, and integration of 1 will be x. Limit is from a to 0 is equal to 1 by 2. Now let's substitute limit. From upper limit we will get 0 minus, from lower limit we will get a square by 2 plus a is equal to 1 by 2. We can simplify this as a square plus 2a plus 1 is equal to 0. So a plus 1 the whole square. So the value of a is simply minus 1, which is given in option A. Ta-da! In this question, we have to find integration of mod x minus 3 from 1 to 5 and mod 1 minus x from 1 to 5. If we talk about our first function, which is mod x minus 3, we can say it will be x minus 3 when x minus 3 is greater than 0, or we can say x is greater than 3, and it will be minus of x minus 3 when x will be less than 3. So here the changing point is 3, and we know that 3 is belongs to our limit, which is 1 to 5. So we have to split our limit from 1 to 3 and from 3 to 5. For x belongs to 1 to 3, your x will be less than 3. For x less than 3, your function must be minus x minus 3. Similarly, in second term, your x is belongs to 3 to 5, or we can say your x is greater than 3, and for x greater than 3, your function must be x minus 3. Now let's talk about our second term. Here we have mode of 1 minus x. So we can say it will be 1 minus x when 1 minus x is greater than 0, or we can say 1 will be greater than x, and it will be minus of 1 minus x when 1 will be less than x. And your changing point is not within the interval of open interval 1 to 5. તો અહીંયા તો સ્પ્લિટ કરવાની જરૂર જ નહીં. So during integration from 1 to 5, your x will be greater than 1. So mod 1 minus x will be 1 minus x. Now we just have to integrate. We will get minus x square by 2 plus 3x. Limit is from 1 to 3. Then x square by 2 minus 3x. Limit is from 3 to 5. And finally, x minus x square by 2. Limit is from 1 to 5. Now let's substitute limit. So after simplification, you will get 12, which is given in option D. Ta-da!